The next learning objective is the importance of GIS in research and applications. GIS has found itself in many applications in real life. These include very small scale applications on an urban scale and even parcel scale, to global scale, where we are interested in spatial questions about the whole world. And this list, this graphics shows various examples of these applications, and I will talk about a couple of them. For example, site selection. If we were to build a new um, facility, let's say a fire station, um, the site selection is an important criteria, and that is a spatial um, analysis that needs to be done, and it might be related to um, which parts of a city are underserved um, for fire incidents. And so, if those underserved areas, and by an underserved area would be which is too far away from a fire station. So if there's a certain area that is significantly far away relative to others um, from a fire station, then that is a potential candidate for building a new fire station. But when we start looking further, then we also start talking about in the site selection, is it accessible? Are there road networks there? If there is a road network, is there availability of water and water hydrants? And so all of these questions start to come into play, and that's where GIS can help answering these spatial criteria um, in figuring out the site selection. Let's look at watershed analysis. So if we are trying to manage a watershed, then GIS can help us, first of all, in inventorying everything that exists in the watershed. And in the watershed analysis, we might be interested in reducing erosion in the watershed, which is eventually, let's say, impacting sedimentation at a downstream dam. Or it could be a preservation of a certain natural habitat in the watershed to ensure that we have existence of a decent amount of vegetation on the surface. So all in all, these are all spatial questions, and these are spatial criteria that need to be considered, and that's where GIS can help in analysis of the watershed. So here are some examples in the civil engineering arena that are relevant to the applications of GIS. So first and foremost, transportation. Um, Within the cities, we have a dense and complex network of roads, and roads have their um, characteristics. For example, number of lanes, one way slash two way, presence of certain signage along the roadside, uh, existence of utility lines above or below the ground along the road, um, existence of intersections and signals. And all of these make it a very complex system. And so, for resource management of a transportation system or expansion of the existing transportation network, all require a good and rich presence of the spatial data about the system. And that's where GIS helps us. It keeps us aware of what do we have in the transportation network resource, how we can manage it, and how we can expand it. And presently, with the existence of smart cars, the cars that are aware of their own presence on the road and that have the ability to navigate over the transportation network, it's even much more needed. And that's where the integration of the mobile devices and integration of the GPS data with the existing transportation infrastructure comes into play. Next, we can look at the watershed analysis again. Now, we briefly talked about it earlier, but here is a watershed, and once the rainfall event occurs, all of that water passes through channels and tributaries and gets to a certain lake. But if there's a city along the way and we are interested in determining the potential of flooding within the city after a certain event, then GIS can help us to do all the spatial analysis. And this is where we integrate the hydrological analysis with the spatial analysis. So hydrological analysis tells us how the water will be converted into runoff. Um, and but then spatial analysis will tell us how the hydraulics will work, how the water will flow on the surface to go from point A to point B, and what kind of energy will it have, what kind of velocity will it have, and those kind of questions can be answered by integrating hydrological models with the GIS or through GIS. Another example is urban development, where um, present day most of the urban planning and development is actually done using GIS. There's a special wing in all the urban offices that handles and creates GIS data. For example, for Clark County, we have GIS Management Office or Gizmo, and they maintain all of the data about the streets and buildings and parcels. Um, and you can go and download that data if you were a developer trying to develop a new location, or if you were a researcher trying to understand how the city has expanded. All of these kind of questions can be answered with GIS information. Likewise, if you were trying to understand how the water will flow within an urban city, you need to know how urban surface or urban terrain is changing from point to point. Um, Target site selection that we earlier talked about, for example, a site selection for a fire station. So consider these 6 spots for different fire stations, and these these regions around them tell us how far that fire station is from a certain location. So yellow is the closest, then the red and the purple. And yellow is an area which is far away from all of these fire stations. So if it is, let's say, beyond 5 minutes distance, if purple represented within 5 minutes, then this little region within the city could be another potential location for a new fire station. So um, site selection is a very important um, um, problem that can be solved with the help of